Hi, welcome to my channel Mathematics Made Easy by Mary MJ. Today we are continuing with chapter 13, Limits and Derivatives. In the last video we were discussing how to apply limits. So if it is in the 0 by 0 form, then we have to either factorize or give substitution method or rationalization. These are the three different methods we have to go for if it is in the form of 0 by 0 form. Now here in this video we will be discussing a theorem, that is limit x tends to a, x raised to n minus a raised to n by x minus a is equal to n a raised to n minus 1. So here the proof is not needed, just we have to understand these are the standard results. So we can apply these standard results in the problems directly, but we should know how to apply this. So if it is in the form x raised to n minus a raised to n by x minus a, then if limit x tends to a, then the answer is n a raised to n minus 1. That is, I will show you one example here. Limit x tends to 1, x raised to 5 minus 1 by x minus 1. So this is in the same form. So 1 means it is 1 raised to 5. So both these are in the same form. Instead of a it is 1, instead of n it is 5. So directly we can give the result. This can be written as n a raised to n minus 1, where n is 5 here. Compare these two results, can see that n is equal to 5, a raised to, instead of a it is 1, it's 1 here, so 1 raised to n minus 1, n is 5, so 5 minus 1, and that is equal to 5. Then another example, limit x tends to 1, x raised to 15 minus 1 divided by x raised to 10 minus 1. So if it is in this form, how can you apply this result? So this we can write it as, we have seen that standard result here, limit x tends to a, x raised to n minus a raised to n by x minus a. So if it is x raised to 15 minus 1 raised to 15, it should be divided by x minus 1. Here also, so here what you can do is limit x tends to 1, I can write this as x raised to 15 minus 1 raised to 15 divided by x minus 1. But it is not here in the denominator, x raised to 15 minus 1 raised to 15 by x minus 1. Then that is an extra term that we have to cancel, that we can see here, that is in the denominator also, x raised to 10 minus, instead of 1 I am writing 1 raised to 10, then divided by the same x minus 1 I am writing here. So that these two denominators will be cancelled, so the same thing. No. So for applying limits we are making in this form. So actually this x minus 1 means if I am taking this as a reciprocal, that x minus 1 will get cancelled. So limit x tends to 1, x raised to 15 minus 1 raised to 15 divided by x minus 1, we can apply the limit. Same way for the denominator also we can apply the limit. So in the numerator and denominator we are applying the limit that x is tending to 1. Now apply the standard result. X raised to 15 minus 1 raised to 15 divided by x minus 1. X raised to n minus a raised to n by x minus a is n a raised to n minus 1. Here instead of n it is 15. So 15 instead of a it is 1. 1 raised to 15 minus 1 divided by Here instead of n it is 10, so 10 into 1 raised to 10 minus 1, and the answer is 15 divided by 10, 5 is common, so 3 by 2. Now one more example. Limit x tends to 0, root of 1 plus x minus 1 divided by x. So directly if I am giving the 0 here for x, instead of x I am giving 0. So root 1 minus 1, that is 0 divided by 0. This is 0 by 0 form. So I have already told you, either we have to go for factorization or substitution or rationalization. Here we can give substitution for 1 plus x. I am giving 1 plus x as y. So when I am changing this part by y, then here also limit also will change. That is, here I am giving x is tending to 0. If x equal to 0, what happens to y? Y will be equal to 1. That is, y is tending to 1. When x tends to 0, y tends to 1. So this can be written as limit y tends to 1, root of 1 plus x is y minus 1 divided by, instead of x can take this 1 to the side, that is y minus 1. Now we can write this in the standard form. How can we write? Limit y tends to 1. This root of y means it is y raised to 1 by 2 minus 1 raised to 1 by 2 divided by y minus 1. Now it is in the standard form. Limit x tends to a, x raised to n minus a raised to n divided by x minus a, and this is equal to n a raised to n minus 1. N is 1 by 2, a is 1. So 1 by 2 is the answer. So this is called, this we did using substitution method. Okay. Now next is limits of trigonometric functions. Limits of trigonometric functions. First one is limit x tends to 0. Very important results. This you have to study. Limit x tends to 0, sin x divided by x is equal to 1. Here no need of studying the derivative of this. So only you have to, no need of deriving all this, only you have to study this result. That is, limit x tends to 0, sin x by x is equal to 1. And the second one you have to learn is limit x tends to 0, 1 minus cos x divided by x is also equal to 0. See, if I am giving directly the value, you will not get the answer as 1. Here also if I am giving 0, x is tending to 0. So cos 0 is 1, 1 minus 1 is 0, again it is in the 0 by 0 form. It is after long steps we are getting that result as limit x tends to 0, 1 minus cos x by x is equal to 0. So you should understand that this is did by using several steps, and after that we are getting these results. We have kept this as the standard result, so we can apply this directly in the problems. So no need of deriving all these things. Okay, can keep in your mind while doing the problems. Then, so I'll show you some examples for this. That is limit ax tends to 0. Suppose what happens instead of sin x, if it is sin ax, here it is given limit x tends to 0, sin ax by ax. But so what happens is that here it is x, sin x by x, here x tends to 0. If it is sin ax by ax, then limit ax tends to 0, then only it is equal to 1. Okay, limit ax tends to 0. What is the value here, what is the coefficient of x here, same thing it should come in the denominator, and that should tends to 0. Same way, limit bx tends to 0 sin bx divided by bx, that also is equal to 1. Now we'll do few example questions. Limit x tends to 0 sin 4x divided by sin 2x. It is not in the standard form, that is we can't apply the standard result directly here. If it is 4x in the numerator, then 4x should be there in the denominator also. So what we can do here is limit x tends to 0. I am writing here sin 4x. In order to apply the limit, 4x should be there in the denominator. Then since this is an extra term, that 4x I am multiplying here. Then divided by, here sin 2x, same way we can write sin 2x by 2x into 2x. Now how to apply limit? Limit in the numerator, if I am applying limit, I have to write limit 4x tends to 0 sin 4x divided by 4x into 4x. Whereas if I am applying limit in the denominator, limit 2x tends to 0 sin 2x by 2x into 2x. We can see that if limit 4x tends to 0, sin 4x by 4x will be 1. Here also this is 1. Then this x can be cancelled and we are getting the answer as 4 by 2, that's equal to 2. Another example, limit x tends to 0 tan x by x, and that can be written as limit x tends to 0. Tan means it is, tan x means it is sin x divided by cos x by x, and that is equal to limit x tends to 0 sin x by x into cos x, both in the denominator. Or it is the same as limit x tends to 0 sin x by x into limit x tends to 0 1 by cos x. Now here if I am applying the limit x tends to 0 sin x by x is 1, and here if I am giving the value for x as 0, we are getting 1 by cos 0, cos 0 is 1, so the answer will be 1. Now we will discuss few questions from exercise 13.1. We will start with the exercise questions. Exercise 13.1. Find the limits or evaluate the following limits. First one, limit x tends to 3 x plus 3. This is a very simple question. Directly you can put the value of x as 3 and you are getting 3 plus 3 is equal to 6. Then second one, limit x tends to pi x minus 22 by 7. Here also directly we can give the value for x. So the answer is pi minus 22 by 7. No need of substituting the value of pi now, because it is just asked to find out the limit. Then third one, limit r tends to 1 pi r square. So this is a constant. So if it is of the form limit x tends to a k into f of x, it is the same as k into limit x tends to a into f of x. Same way here, pi is a constant, so pi into limit r tends to 1, r square. That's equal to, if I am giving value for r as 1, we are getting the answer as pi. Now fourth one, limit x tends to 4, 4x plus 3 divided by x minus 2. If I am giving the value 4 here, directly we can apply the value, that is 4 into 4 plus 3 divided by 4 minus 2, that is 16 plus 3 by 2, which is equal to 19 by 2. Direct putting the values. Then question number 5, limit x tends to minus 1, x raised to 10 plus x raised to 5 plus 1 divided by x minus 1. That's equal to, if I am giving value for x as minus 1, we are getting minus 1 raised to 10 plus minus 1 raised to 5 plus 1 whole divided by minus 1 minus 1, and that is equal to minus 1 raised to even number is positive 1, minus 1 raised to odd number is negative. So 1 minus 1 plus 1 by minus 2 is equal to minus 1 by 2. Question number 6, limit x tends to 0, x plus 1 raised to 5 minus 1 by x. So this is of the form, it is same as that of the standard result, x limit x tends to a, x raised to n minus a raised to n by x minus a. Either we can go for substitution method or directly we can do it. If it is substitution method, I have to give x plus 1 is equal to y. So if x is tending to 0, y is tending to 1, and this x can be written as y minus 1. And this limit, what happens to limit? Limit y tends to 1, instead of x plus 1, y raised to 5 minus 1 raised to 5 divided by y minus 1. We can directly give the standard result, 5 into a is 1 raised to 5 minus 1, that is 4, answer is 5. So another way is without substitution also we can do, that is here x plus 1 raised to 5, this is limit x tends to 0, x plus 1 raised to 5 minus 1 raised to 5 divided by, instead of x we can write x plus 1 minus 1, that is x itself. So now it is in the same form as in the numerator, in the same form. So here also we have to change the limit. So instead of x tends to 0, we can write x plus 1 tends to 1. That is the same as x tends to 0. So x plus 1 tends to 1, x plus 1 raised to 5 minus 1 raised to 5 divided by x plus 1 minus 1. And this applying standard result, 5 into a is 1 raised to 5 minus 1, the answer is 5 itself. You can go for any of these method. Now next one, question number 7, limit x tends to 2, 3x square minus x minus 10 divided by x square minus 4. So here if I am giving the value of x as 2, what happens? 3 into 2 square minus 2 minus 10 divided by 2 square minus 4. So 3 into 4 is 12, 12 minus 12 is 0, here denominator also 0, so this is of the form 0 by 0. So we can go for factorization. This one it's better to go for factorization. Limit x tends to 2. How can you factorize the numerator? For that you have to take the first term and the last term, multiply. That is minus 30. Find out the factors of minus 30. That is such that its sum should be the middle term. So minus 30 can be factorized as minus 6 into 5. So what you have to do in order to factorize such a type of question, that is, if coefficient of x square, some number is coming, what you have to do is take the first term and the last term, multiply, and then find the factors of that. We are splitting the middle terms. So this can be written as 3x square minus 6x plus 5x minus 10 divided by x plus 2 into x minus 2. That is, limit x tends to 2. Here 3x is common, remaining x minus 2. Here 5 is common, remaining x minus 2, whole divided by x plus 2 into x minus 2, and the numerator all x plus 2, x minus 2 taking outside, limit x tends to 2, all x minus 2 taken outside, remaining 3x plus 5 divided by x plus 2 into x minus 2. Common terms can be cancelled, that is, x minus 2 is common, can be cancelled. Now we can apply the value for x tends to 2. So we are getting the answer as 3 into 2, 6 plus 5 divided by 2 plus 2. So the answer is 11 by 4. Next one, question number 8. Limit x tends to 3, x raised to 4 minus 81 divided by 2x square minus 5x minus 3. So if I am putting the value or giving the value for x as 3, we are getting it as 3 raised to 4. 3 raised to 4 is 81 minus 81 divided by 2 into 3 square is 9 minus 5 into 3 minus 3. So 81 minus 81 is 0, denominator also it is 0. So it is of the form 0 by 0 form. So either we can factorize, here only factorization is possible. So how can you factorize this? Limit x tends to 3. X raised to 4 minus 81 means x raised to 4 minus 3 raised to 4. That is x square minus 9 into x square plus 9 divided by, how can you simplify, how can you factorize this? For that you have to split the middle term. For that you have to take the first and last, find the product, that is minus 6. Minus 6 is the same as minus 6 into 1. Adding, we are getting the middle term. So you can split this as 2x square minus 6x plus x minus 3. Or that is, limit x tends to 3, x square minus 9 into x square plus 9 divided by, here common terms 2x, remaining x minus 3 plus x minus 3. Again, numerator can be factorized. Limit x tends to 3, x square minus 9 can be written as x plus 3 into x minus 3 into, last term is x square plus 9 divided by x minus 3 is common, remaining 2x plus 1. X minus 3 can be cancelled. Now we can apply the result, give the value for x, that is x is tending to 3. So what happens to the limit? 3 plus 3 is 6 into 3 square, that is 3 square plus 9 divided by 2 into 3 plus 1. That's equal to 6 into 9 plus 9 is 18 divided by 6 plus 1 is 7, or that is 18 into 6. 8 6 are 48. So 108 divided by 7. That is, limit x tends to 3, x raised to 4 minus 81 by 2x square minus 5x minus 3. So the remaining questions we'll be discussing in the next video. Thank you for watching my video. Those who haven't subscribed, please like, share and subscribe, and also click on the bell icon for more updates and notifications. Bye.